Very good afternoon to all of you. And on the occasion of Science Show Conclave and our Diamond Jubilee celebration, okay, today we are presenting a science show on rocket science. Myself, as already introduced, Prashant Kumar Biswal, and my team, my colleagues, Mr. Adiga and Mr. Neeraj will be performing some demonstrations. Okay, I think a rocket is very much familiar word to all of you. We all play with rocket. We see a rocket, and the history of rocket goes long back, like in 13th century. It was first gunpowder was invented in China. Then in India, first Tipu Sultan is credited for using the rocket. His father Hyder Ali and Tipu Sultan, they fought with English in Anglo-Mysorean War. Okay. So whatever the rocket, whether it is a small firecracker rocket or big rocket which takes satellites to the orbit or people to moon or people to ISS, all the rockets works in a simple principle. Let us start with this simple simple principle demonstration. I am having here a miniature of Mysorean cannon. I think all of you know this. It is a real cannon. We can fire even 10 mm cannon ball in this. But today we will not fire live cannon. Live we will fire blank. So cannon is it is like a barrel mounted on a cart, and you can see one side it is open, other side it is closed, and there is a small hole in this barrel which is known as charge hole. And let me put a fuse in the charge hole. Okay, good. Yeah, I am putting some. This is a mixture of potassium nitrate and sucrose. Okay, it will just act like a channel to get fire to this fuel. I am adding gunpowder to this. 1 spoon I have taken. Okay. Okay, let us put one more dose because Science Show Conclave is going on. Some cotton wadding to make it fix it tight. One more cotton. Okay, it's tightly packed. Okay, are you ready for this lunch? Okay. So my friend, he is very much interested in igniting. Okay. So from the beginning he told, sir, whatever you do, but igniting work you give to me. Okay. So let us see what happens. Yeah. It may be quite noisy. You can, if you want, you can. Oh, oh, this far. Yeah, will. This one first happened. The screw. Pardon? You could have bring a screw. Agala, screw you need. Scissor. Okay, the fast bigger one give. The screw you needed. No, come this side. The screw you would have brought. Okay. Okay. You go. But this is hot. Yeah, give that rod. Ram rod. 1 minute. Yeah. Put this. Ram rod. Oh, this is not gone inside. No, this. You bring that rod? Yeah. Let us see. Okay. Okay. No. Something is there inside. No. These papers are there. 1 minute. Okay. Let us see. Okay. Now you can Oh, yeah. Sure. Okay. So you observed when the fire happened, did you observe that cannon went backside? Because so all of a sudden what happens? So here the basic principle tells that so hot gases escaped from this end of the barrel with the cotton wadding what I have given with a high speed, and with reaction to that this cannon came backside. Okay, the simple physics tells here the conservation of momentum. So some momentum gained by the hot gases, escape gas, and because of that some momentum got this cannon. Okay. But this it happened everything instantly, and once one blast, then this cannon went for some distance, but it is not getting continuous energy to run. But for moving the rocket or launching the rocket, we need continuous energy supply. Otherwise, it will not be able to go to. So continuously energy is required. Okay, we'll come up with another demonstration. Liquid yeah. I have made arrangement with the car, okay, and one bottle on the top of this. Let me put okay. So it is somehow got leakage. One more time. Some more water will put. Some more water you have to put. Good. So did you observe that? So I put little liquid nitrogen inside this bottle and closed the compressed air, compressed air inside, liquid nitrogen converted to air. That's what it is. Its expansion ratio is 1:694 or nearly 700, and because of that expansion, there is a compressed air, pressurized air. When I released this, because of this, air comes out with a very high speed. This bottle got a thrust, but it has not got so much distance. Compressed air will not have that much energy to move rocket, but we need some combustion engines for continuously taking the rocket up. And so you all are familiar with this internal combustion engines, petrol engine, diesel engine. So what is happening there? We are using fuel we are using, then oxygen it takes. Chemically, fuel and oxygen they mix, they burn to get us energy. So can we get, so same way, can we use like that engine for using rocket or getting the thrust? Same principle used in jet engines. So jet engines, they take oxygen from air and fuel. Normally the fuel for jet engine is ATF or aviation turbine fuel, or normally it is a bit kind of kerosene, atmosphere. We cannot take the jet engine to the space. We cannot operate the jet engine to take or launch the satellites. Okay. So here in this cannon, you have observed that I used gunpowder. Okay, gunpowder is readily not available. We searched throughout the Bangalore to get gunpowder, but we didn't get. We prepared in our lab. Okay, gunpowder. Pardon? Yeah. So gunpowder is a mixture of three components. One is charcoal, and one more is potassium nitrate, and one more beautiful element, sulfur, yellow element. So here, can you tell me which is here, which is the fuel, which is oxidizer? Yeah. So this here potassium nitrate is maximum 75% is potassium nitrate, sulfur is 10% and 15% charcoal. We mix together, we get, so charcoal is the fuel, burns, sulfur adds again for burning, potassium nitrate works as a oxidizer. Okay, when potassium nitrate get heated up, oxygen will release, and so this, they are even without oxygen also. It came up. One minute. Okay, these are one kind of rocket motor, solid fuel motor. Okay, when it burns, it produces lot of gases, and so this I wanted to show you, but I could not make this experiment. I wanted to show you in a volume where the water is filled, and once it burst, how much it has expelled the water. So normally 1 gram of solid fuel motor, this fuel can displace almost 270 cc. That much volume it can produce. That's what we are getting thrust. And so not only the fuel, okay, you get the fuel, you get the oxidizer. Okay, for making a good rocket or good fuel, we need to mix the fuel with oxygen in the correct proportion. Okay, and here I am having one demonstration for you. I have kept a channel. Yeah, 3 bottles to give me. Okay, now let it give me 2 or 3 also. Yeah, 3 bottles I have taken here. These are filled with fuel with oxygen. Bottle number 1 is more fuel, less oxygen. Bottle number 2, less fuel, more oxygen. Bottle number 3, okay, you are telling half fuel, half oxygen. Okay, let us see what happens. So I am taking this bottle number 1. Okay. Now igniter man is ready. What do you expect? More fuel is better? What do you expect? This is more fuel, maximum fuel, very less oxygen. What will happen to this? First let me target, okay, it will hit there. Okay, let us see. Ready? Yeah. So it will move hardly some 2-3 centimeter. Okay. Bottle number 2. Okay. Here it is less fuel, more oxygen. Okay. What is your expectation? Yeah, less fuel, very less fuel. Only 10% fuel is there, and okay. Let us see. Yeah. Now the final one. Okay, now already you know this is 50-50. Okay, as per Mr. Yogesh, it is 50-50. Let us see. Oh, yeah. So how many of you are agree with Mr. Yogesh that it is 50-50? How many of you agree with some hands are coming up there. Others are not agree. Our ATM people are not agree with me. Okay, good. Okay, for understanding this, we need to understand the molecular formula of the fuel. The fuel I used here, methane, CH4. Okay, carbon and 4 hydrogen bonded with carbon molecule with 4 single bonds, and oxygen is used. So as per Mr. Yogesh, he told half, 50-50. So if you take 50 methane, 50% oxygen, does it burn completely? Does it burn completely? No. So this carbon will mix with this 2 oxygen molecules. What it forms? What is this? Hey, I got confused. This is carbon dioxide. Carbon will burn with 1 oxygen molecule to become carbon dioxide. Then remaining is another 4 hydrogen atoms. Then we need 1 more oxygen molecule to burn this completely 4 hydrogen molecule to make 2 H2O water. Okay. So here for complete combustion we need 2 volumes of oxygen, 1 volume of fuel. So in this third bottle I have taken 2 parts of oxygen, 1 part of methane. But it differs for different fuels. If you take ethane or propane or butane, if you take propane, first I tried with propane, but it is very, if you are trying, you don't try it, because ratio will be 1:5. Okay, so that we will have very less difference. Okay, thank you. Yeah. What is this? Yeah, good. Can you wipe this a little bit? Can you just bring a cloth that will do. Yeah, I am having in my 2 hands cottons I have taken. Okay, you all know cotton, very good. If you burn this cotton, okay, yeah, come. Best. Thank you, Ramesh. Yeah, if I'll burn this cotton, what will be the final product? Carbon. Yeah, carbon. Okay, let us burn this. No, you give this. Okay. On is there. Yeah. So you see, it is burning, and okay. Same way I am having other cotton also. Okay. What do you think if I'll burn this? Same thing. Okay. Mr. Igniter will ignite. Let us see what happens. Cameraman, focus karo, like yesterday. Yeah. You just show this on table. Did you find anything there? Okay. It completely burnt. Matter cannot disappear like this. Okay. So where it went? Hmm? Complete combustion happens when? Okay. So you know, for building the fuel of the rocket, we need fuel separate, oxygen separate, oxidizer separate. But if you can pack the oxygen molecules itself in the molecules itself, okay, then molecules inside the molecule itself, oxygen is inbuilt. Like so, the which one burn completely? This is called as nitrocellulose. Nitrocellulose is, and actually we prepared this in our lab. They have our science communicator helped to prepare this. So this, if you keep the cotton inside hydrochloric acid, nitric acid, and but here you used nitric acid and hydrochloric acid and potassium nitrate, and then you dip it for 24 hours, then clean it and dry it. It will become the nitrogen will be in the cellulose molecule itself. It will go, and this was discovered accidentally by in 1846 and German Swiss scientist Schönborn. Actually, when he was doing some experiment in the chemistry experiment in his kitchen, he spilled sulfuric acid and nitric acid, and he wiped that in a cloth and dried it, and then next day when he fired, it completely fired. So this was this discovery was accidental. Okay, can we use this to make a rocket fuel? Okay. So same thing. Very one small demonstration. Yeah, here I have taken a marker and removed the cartridge from inside this marker. Okay. Give this. One minute. Should have a little more. Okay. Yeah. Now you observe. Okay. So did you observe that nitrocellulose you have put inside this pen, and when it completely burnt, complete combustion happens, so the hot air which escapes, it got, so like this, then it is also experiments where the control required are in this. So this can be a fuel of rocket also. And what is the next one? Okay, we talked little more about the chemistry part of the fuel. Okay, let us come to the physics part. I need 2 volunteers. Oh, you both are there in front. Come. Good. Yeah. So 2 sticks for you, but not for fight with each other here. Okay. Yeah. Very easy task I'll give to them because they are our guests. They have come from Mumbai. Okay. Not very easy. Your task is, okay, good. So you have to balance this stick in your finger like this. Okay. So he's thinking what the task is this, not that. Okay, good. Oh, you are also doing the same thing. I'll make for you little hard. Okay, don't feel bad. Little hard, but for you stick will be like this. Okay. Okay. Yeah. Don't put up. Only you are making like this now. Just in the fingertip only. Okay.
To balance, sir.
Yeah. Oh. What happened? The same thing you see, he's easily, very easily he's balancing, but okay, let us try. 1 second. Yeah, difficult. Okay, if you try also, you can make it. Okay, good. I'll tell you. Let him. Yeah, good. Okay, so little balance required for him. You see, for easily the same thing, same mass, but for only the direction of this tube, he can easily balance it. Even if I make little disturbance also, you can see it is coming to the same position. Okay. But in his case, thank you both. Thank you, sir. Yeah. But what about to Mr. Yogesh case? You see, when he is balancing, so he has to move his hand like this for making the balance. Okay. So to understand this, first we need to understand about the, okay, this is a rocket. Okay, we have to understand about center of mass and center. Now, how to find out center of mass of this object? Now you see, if I am keeping it in this, so this point is the center of mass of this object. Okay. Now center of mass means this, in this particular point whole mass is like concentrated. So in this case, center of mass is down here, center of pressure. Even if little disturbance also, it comes to this equilibrium position. But in his case, so little disturbance itself, it will add up to the more, and it is disturbance will be increasing. To understand that, we are having, what is the next one? Yeah. To understand this in better way, we have one simple experiment. Yeah, my friends, I request them to distribute some paper planes to you all. Yeah. First, distribute first. Yeah. Yeah. Give, some people also give in the back side. Okay. Sir, please don't disturb that paper plane. Yeah, I have given two color of paper planes. You can see one is white color, one is green color, light green color. And in this, it is already one paper clip is attached to that. Okay. If is, please see that if it is white color, the paper clip will be in the back side, and it is light green color, paper clip will be in the middle. Okay, very good. Same paper plane. Now, I think you all are very good with the flying rocket. Normally, when you are in the school, flying rocket to the lecture. Now, if you are angry on me, okay, you can target me. Okay. Now, first one is not everybody at a time. Not everybody at a time. Yeah. Pardon? First white. Okay. So white person, the persons having white aeroplane can target me. Okay. And look at, if it is not there in the back side the clip, you can adjust it, the clip. But yeah, don't move the clip from the back. That is cheating. Okay. That is cheating. Yeah. So keep the clip in the back side of the rocket. White planes, you can target me. Okay, let me put the goggle. Okay, put white. Yeah. Oh, yeah, very good. You see, all white planes. Nothing has come to me. Okay, now it is time for the people having. Sir, sir is very much angry on me because he wanted to do first. But already, sir, I am very sorry that. Yeah, I am very sorry that because these gases and all what I feel, it may, that's what, otherwise nothing else like that, please don't mind. And what I was telling, okay, so you can, goggles, first safety goggles, if something will come. Yeah, correct, yeah. So now this, yeah, ready? Yeah, 3, 2, 1, go. Oh, yeah. So you can see, yeah, good. So some paper planes has come to the stage. Okay. So here, the paper planes which are having the clip in the back side couldn't come, but the thank you, sir. Thank you very much. It's my pleasure. Okay. Yeah. So here the same thing what I was about. Okay, I'll explain you this later. Let us do another one demonstration. Yeah. Yeah. So imagine this is the rocket. What is the white aeroplane? This is the rocket. This is the green. The paper planes. Okay. Same thing now. I'll put this here. I'll put this here. Can you switch on the fan, please? That's all. That's all. That much distance. Yeah. Switch on the fan. ಇಲ್ಲಿ ಆನ್ ಮಾಡಿ. Okay. Yeah. Oh, it already started. You say, so so this air is blowing, air is coming towards the rocket. Now you see, if I release it, so it is, even if I bring it to this stable position, it is turning back. So this is called as unstable. Okay. But now where center of mass, the center of pressure is behind the center of mass. Now if we bring another one rocket, which center of mass is in front of the center of pressure. Okay. Now you see, it is quite happy. Okay. So even if I disturb it, again it comes back to this its position. Okay. So what do you feel, that center of mass keeping in the center of, in front of center of pressure is better? Yes or no? Good. Then how will keep the center of mass in front of the center of pressure? That means we have to add more load to the nose cone. Okay. So which is not a good idea. Is it a good idea putting more load to the nose cone? No, because taking this much mass to the space itself, it is very difficult. We have to spend a lot of energy to take more mass to the space. Instead of that, you have to bring the center of pressure backward by adding the fins of the rocket. So where the area pressure, this surface area will increase. So when he was doing like this, so it is like a rocket. So whole rocket is unstable because lot of mass will be in the down, more mass will be in the down. Now you see, so when I am stabilizing this, I am moving my hand towards this side. So the biggest ever rocket made, which is during the Apollo missions, Saturn B rocket, it is almost nearly 36-story building height, that much big, and nearly 367 tons of fuel, and the motors, rocket motors, will be near the size of one house. Okay. And when the rocket lifted off, this much big rocket, everything is unstable. So what the motor has to do there, when the rocket has to go up, if it is tilted, the motor has to correct this. That means the motor which is behind the rocket, it has to correct the position. Okay. So very big hydraulic rams will be there for correcting this. Yeah. So I'm having here real rocket of firecracker. I'll not fire it here. Okay. Can you guess if we caught the stick here? What for the stick is used in this? What for the stick is used in this? Oh, बोतल में डालने के लिए, very good idea. Okay, correct. To yeah, so because he has used, आपने ऐसे ही यूज किए हैं उसको बोतल में डालने के लिए, तो बोतल में डालने के लिए भी इवन छोटा सा भी कर दे. If you will caught this stick, will the rocket will fly? Rocket to fly, but yeah, where it will go we do not know. So this is as like the stick, where in the rocket the fins are used. Here the stick is used to stabilize this. When this will go up, when this will tilt, this will again stabilize this. If the stick will not be there, it won't go up. It will go somewhere's window, somebody's window inside. Okay. Oh, this one, good. Yeah, for rockets, when the Apollo missions, moon missions happened, people have gone to landed on moon, and we have talked a lot about this solid fuel, liquid fuel rocket, and this liquid fuel, solid fuel. Everywhere we need a igniter. We need a source of ignition. But in the lunar missions, where there are a lot of risk, because people has to go land on the moon, again they have to come back, lunar module will land, there will be two engines, descent engine and ascent, and there we need so much of reliable source. Reliable means it should not, it cannot fail. So in that case, the fuel is used called as hypergolic. Hypergolic means, I think many people will be knowing, where the spontaneous ignition happens. We no need of any source of ignition, and if the fuel, there will be a fuel tank and an oxygen oxidizer tank. When they combines, automatically it will catch fire. Okay. So normally the hypergolic fuel used in the lunar missions, in Apollo missions, it is UDM, erosine, okay, unsymmetrical dimethyl hydrazine and nitrogen tetroxide. So these chemicals are, it is, I didn't get that. To simulate that, we have an experiment, famous experiment, you all know this. Okay. So this is the safest way to perform this hypergolic reaction. Sufficient agala. So without any source of ignition, yeah, thank you. But it is the safest way to show the hypergolic ignition without source of ignition. I have used potassium permanganate and glycerin, which all of you know, and there it was used nitrogen tetroxide as oxidizer, and fuel is hydrogen terminated polybutadiene. Okay, and unsymmetrical dimethyl hydrazine that is used. That is very dangerous chemical, and is it good? Good. Here you see, I have taken a gas jar filled with some gas. Okay. No need of all. No need. This will give you one. So now I see a glowing splint. Let me bring it inside this. What happened? Okay. So you saw the glowing. When I brought this glowing splint inside this jar, it got fire. I caught fire. Okay, what could be the what could be inside this jar? Oxygen. Very good. Yeah, right answer. Is it right? How many of you tell it is right? No hands. It could be oxygen. Very good. Nothing else can. Very good. All of you know from the beginning, if anything, any glowing splint, if you bring to the gas, it is oxygen. But it was a bit tricky question. It is not oxygen, something else. Huh? Huh. Oxygen gas अगर concentration है तो वो जलेगा. Okay. So this gas, anybody else? This is nitrous oxide. Have you heard about nitrous oxide? So nitrous oxide, laughing gas. If you are unfortunately met with accident, you broke your leg. If you are going in ambulance, if you are complaining ambulance crew that I am having some pain, definitely suddenly they will give you some nitrous oxide. You will get a relief. Nitrous oxide is used as anesthesia painkiller. Okay. So nitrous oxide can be an oxidizer. Okay. And here, for see this nitrous oxide can be oxidizer for a hybrid rocket. We talked about solid fuel rocket, liquid fuel. Liquid fuel we used liquid hydrogen itself is the liquid fuel itself, and liquid oxygen is the oxidizer. Okay. But nitrous oxide can be used as a hybrid fuel motor where the both solid and liquid can be there. And here I have taken in this jar nitrous oxide. Okay. Light off, 1 minute. What is the time? Okay. Both okay? Okay. Then, okay, I'll end up with this this demonstration. Okay. I'll take. Close my better. Where is the glove? 1 minute. Bring the spatula. Bring the fire. Sir? No, sir. I am not taking. You keep ready everything. Okay. So, not this side. Not this side. Okay. Yeah. Do this. Open. Open it. Hold. You do this. Okay. Yeah. So you do this, perform this. Otherwise I'll bring the igniter. Then yeah. Yeah. No, that's all. Yeah. So I have put little carbon disulfide inside that. Yeah. Yeah. So you can see the beautiful blue color light inside that. So it should have given a oof sound. This is called as barking dog experiment. And lights on. So here nitrous oxide I have taken as the oxidizer gas, and when carbon disulfide we added, carbon dioxide gas, when we opened the cork, carbon dioxide escaped, only sulfur dioxide and nitrous oxide will be there, nitrogen dioxide, which will act as a oxidizer. Sulfur will act as a fuel, and you can see this yellow color sulfur element. Okay, thank you all. Hope you all might have enjoyed. I do not know. Thank you one and all. And in the last, I need to acknowledge my friends here, my colleagues here. I got a very good support from mechanical section, very good support from electrical section and all sections. And very big thanks to the science communicators and other people, those who have helped me in making this experiment within a few span of time. And frankly speaking, this was the first show. I have never made this show earlier. Thanks to one and all for listening to me. Thank you. Thank you.
Check. Thank you, Biswal sir, for the cool experiments. Next, we have Mr. Tarun Kumar Das from BITM Kolkata, and his session would be on Space-tacular Science Show. So looks like it's a day for space science enthusiasts. Looking forward for the two. Time. So just one small point, like let's all stick to the time of 20 minutes that has been allotted for the session. Thank you.
मोबाइल तो है ठीक है नो प्रॉब्लम अच्छा वेट एक्सटेंशन बोर्ड इधर से यहाँ पे दो ओके keep it here and that blower ये फैन हटा दो इलेक्ट्रिकल इसमें वहाँ पे बैठे दीजिए एकदम राइट में बैठे हाँ उसको साथ एकदम राइट साइड we have the pipe balance yeah utmost right side hello time is required right yeah that's all my show started ना ना बंद करो ना ऑन कर दीजिए कुछ नहीं करेगा आप दे दो आई एम कंफर्टेबल हेलो अच्छा ठीक है इसको मेरे टेबल में रखो अच्छा कैमरा ऑन ए सॉरी माइक हेलो Hello. First of all, I'm so grateful that I have got the chance to present myself. And first of all, here, congratulations, Shubhanshu Shukla. It is just about few minutes, maybe, we are going to dock. That is, EXIM formation is going to dock to International Space Center. And I requested the authority to give me the chance. I don't want to miss that VITM and all other NCSM people should go through this type of celebration. I got the chance, and so many things. Which fell first? The bottle or the balloon? Are you sure? Which is falling first? You made the mess, right? Would you please help me? Chalo, हमारा show शुरू हो गया. That same experiment in a different version was done in 1972 by David Scott. Where? On the surface of the moon. But from the very moment, I would like to show you that if I drop this box and, this bottle, which one will fall first? Same times. Are you sure? You are really brilliant. I have this balloon with water and this packet. Which one is falling first? Oh, okay. I will come in details of this if I get some times. So first of all, let me stand here. I'm Tarun Kumar Das from BITM, and I'm presenting as the Space Spectacular Show. It's a show on some little knowledge of space technology, that mostly the rocket technology, and some facts of the moon and the earth. And easily we will try to present because it is targeted to the school group, right? School students. Okay, so now let me start. Let me imagine that I'm drawing one line, and on my right side there is one group. You people are belonging to a group. That color of the group is blue. And what's the color of this group? Red. Imagine it is red. What's the color of your group? Blue. And what's the color of your group? Yeah, brilliant. Brilliant. So let's go to the moon. Who wants to go to the moon, please? Ah, that boy. You please satisfy one condition, and I will send you to the moon. I promise. Right? This is not enough for me, this table. But okay, I will manage, no problem. I got these two balls. This is smaller, this is bigger. Now if I drop it, see, it's jumping around 1 foot high, right? And this is almost like that. But if I take these two, and if I drop them jointly together, what will happen? 1, 2, wow, it touches the ceiling with a high speed. Trust me, I think that your name is Rajesh and Jogesh. You are two brothers. Now, Rajesh, you take 8 balls and take the 9th one on top of the 8 balls and take just one end, a small end, chitty, right? And you just keep it on there and just go down. Hold it tight all together, then stand up and just from a certain height, about 1 meter or a bit more, and just point this towards to the moon and release them together. You know the change about transfer momentum. You know the energy conversion. The thing is that, trust me, it is hypothetically, maybe theoretically proved that this ball, it achieves a velocity of about 7 miles a second or 11.2 kilometers a second. That is called escape velocity. And trust me, it can reach to the moon. And if you can satisfy one condition, I keep the ball there, please come here and sit like the chant, taking your hands and legs up. Only the very simple condition, you come and sit, taking your hands and legs up, I will send you to the moon. Are you ready to go? Then come below. It is possible. Is it feasible? Absolutely not. So we will go to the moon. We'll go to the moon. I think that Biswal showed you the rocket. May I take the help of the model of the rocket? What is that? Here. It wants to go to the moon. Suppose, imagine. Arey, ye to jayega. Kaise jayega? We need some fuel, right? We need some fuel. He talked about so many things that this may be used as a propellant, as an oxidizer. I'm not going in details. But in a very simpler way, I can ask the question to the students. And I'm considering you, just excuse me, you are the students group. May I do it? Yes. And I have one pipe balloon like this. Pipe balloon like this. Ouch! Actually, I'm in a hurry. Madam given me just 20 minutes to 25 minutes time. I'm in a hurry, but am I doing intentionally? Trust me, I'm feeling nothing. Habituated, practiced. The question arises, and generally we ask the question this way. Whenever your mother cooks, or maybe father, maybe anybody cooks, right? You see the burner. At the burner, you see the fire. The automatically question arises, why the fire is not going through the pipe and going into the... You know the body language. Yes, thank you. Brilliant. So, why it is not happening? Then the students, the people, the common people, they start saying so many answers. But the answer is very simple, very simple. See, I will do something. I got permission from VITM authority. May I do it, sir? May I do it, man? Yes. Don't worry. I'm joking, I'm joking. You see, see, it's burning at the mouth. But why the fire is not going in? See, my hair is not so big. Trust me, I'm practiced. But if I do it again, see, I want to do it again. See that the fire is at the mouth of the balloon, but why that fire is not going back to the balloon inside and making the whole thing like this? Because when I did this, intentionally I did this. I wanted to take the air out. You know, the 21% of the air is oxygen. Oxygen is required very much. Oxygen is required very much. You do one thing, you just go to your home and take a big nail and during the whole night, tang, tang, tang. Try to make a hole. Next दिन सुबह में हर घर में boom, boom. So don't try to be the emperor of Rome, okay? So now, this experiment we can do in a very easier way. I'm very much thankful to the authority, VITM authority, that they have supplied me 2 balloons, right? 2 inflated balloons. Which color you prefer? The blue group? Blue, quite nice. And red group, I'm sorry, I have the yellow group, yellow balloon. Which color you prefer? Yellow. So first, blue I heard, I choose with the junior one, right? So I take this at my back. And where is the nitrogen? What is the nitrogen, boy? Supply me. Oh, there is a box. Please, 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 please. And I want to do this. See, I have a paper inside this beaker. And is it there? You be my guinea pig of the experiment. What's your name? Ramesh, please extend your hand. Yes, your hand. Don't shake my hand. Corona 2 may be there. Right? What we can do is that I take this. Stretch your hand, boy. Stretch your hand. May I let it fall? Gee, I can't. But supply me more from the can. Thoda sa aur daliye isme. I need more, I need more. There is one balloon. I don't know. Authority has given me the balloon. And I'm burning the paper. And I'm sure you cannot see the flame so good. Right? It's not so visible because lights are on. Right? Lights are on. Okay. What's your name, boy? Ramesh. Ramesh. Thank you, Ramesh. Now I take this advantage of this balloon. I just insert into the liquid nitrogen, neutral nitrogen. You know the temperature is minus 196 degrees Celsius, right? What I want to do is that, yes, no, wrong message should go. And yes, Ramesh, please come. Can you put this on? Hurry up. We're in a hurry. Ready? Now I just take this. It's burning still. Chalo, you are going to sacrifice. Are you going to sacrifice? Are you going to sacrifice your hand? Hold this. Yes, he's ready to sacrifice. Now I take this. Oh, be careful. It happens because whenever you are in a hurry, I take this liquid. Now I drop this liquid here. See, wow, it burns again. It was almost done. See, it is so bright. Can you see? So, you know the people, which gas it is already filled in. I repeat, the gas is definitely oxygen. Oxygen, sometimes kerosene, sometimes liquid hydrogen may be used to get the force, action, reaction. Okay? And now, Ramesh, don't go away. I got a beautiful assistant like you. What I want to do is that I got so many papers. Even VITM gave me this, right? With your permission. I just tear it, right? I just crumble into there and I just burn it because this group is waiting for me because they have chosen the yellow color. And hey, it is Indian. This is Indian lighter, I think. It works very well. Now, are you ready, boy? Are you ready? Now hold this. This time we should not make any mistake, right? And no mess up. I get that liquid, can you see, on spot? And now see. Why don't you clap this idea to inspire me? So, for any combustion, right? Any combustion, you need oxygen, right? And we have evidently proved that yes, this oxygen can be used for any combustion. Thank you, thank you. This is mine. This is mine. Give it back to me. This is back to me. Thank you. Clap to him, please. Clap to him. But now suppose that our rocket is ready. Imagine that this bottle, where is the rocket? Biswal, yes. Our rocket is now ready with the fuel, everything. With the oxidizer, everything. If you use solid or liquid fuel. Now, it wants to go, but you must imagine, you must see that the shape of the rocket. I asked for a blower, but I have got this blower. I'm thankful, but it's not so powerful. But still, I want to show you something. I got this balloon with water because on spot I got this idea. It is floating, right? If I drop it down, no problem. I got this bulb. I'm sure that if it glows, I can prove, I can reach to my target. Here is that. See. It may float. And it is floating, though the rate of air is very weak. But it is floating. Better do one thing. I take the plug out. I take the bulb only, and I just release it. Wow, it's floating. Can you see? Why don't you clap this? It is floating. I'm telling you, this bottle, even it cannot float so good because the rate of air is very weak. But in all the cases, oh, it's floating! Wow, it's floating. I'm so lucky. And you know that this type of bottle, the balloon, the shape of the balloon, the shape of this bottle, and you can see the shape of the rocket, it's called the streamline shape. The streamline shape is very important. Just for the less friction, right? Just for the less friction, just for the less consumption of the fuel, right? Okay, so shape matters, okay? Now, so suppose that we are there almost reaching to the moon, almost, because there is very shortage of time. We're almost to the near to the moon, right? Now, on the surface of the moon, when the Eagle landed, when the lunar module, Eagle, 1969, landed on the moon, Neil Armstrong said something. What did he say? Now, that's the problem. Thank you very much. Actually, Tranquility Base here, the Eagle has landed. But he was talking from inside the lunar module, Eagle. But when he stepped onto the moon, I asked generally the question to the students, which foot he stepped on the first time? There are only two options. Tell me any one. Which one? Left foot. When he just landed with the left foot first, he said, that's one small step for man is a giant leap for mankind. I will come to that particular point. We heard from the earth, we earthlings, we witnessed that history, 1969 in the month of July. From the blue group, I want to call one assistant, I would say better. Yes. And from here, Biswal, please come. And I will give you 2 balloons. One for, which color you prefer? Take it. You are wearing green and we are choosing it. But no blue is there. Choose anyone. Anyone! Biswal. Now, you just take your hand like this, do like this, do like this, do like that. Why are you using your balloon? Use your hand. I told you. Don't wear it. You are a very good boy. And you also do. Now, I take the rest one. Is there any sound? Well, it is enough, sufficient. Don't peel off your skin. Now, see, there is no sound, Biswal. But now, I take some water. Buddha Bangia, it is wrinkled, right? Pantaloon. Wow, the same sound, I get this. You know the signs? So it is undulated, it is wrinkled, friction, vibration, that causes sound. But why I am just trying to incorporate this spectacular show, you will come to understand. What I want to mean is that you can do this very easy. Do it. Now, blow! Blow in between. Blow in between. Wow, brilliant. And why don't you clap then? Brilliant performer, brilliant. बस एक बार चांस मिलता है ना, कुछ होता नहीं है. टाइम दे दिया ना मैडम हमको. Now see. Wow, can you do this? You can do this. You can do. NCSM people generally does with this. They do with this. I will do also. Do it. Wow. But now you just stretch it. Whoa, brilliant, brilliant. Just elephant call, right? Ah! So excited. You take mine, You are junior. You take mine. You can do this. But you see, every time we are enjoying all this, we are having fun with this type of experiments with the properties of that the vibration, right? Friction causes vibration causes sound, right? More than if I okay, just do like this one. Hey, Bishwal, you are senior to him. Give it to me, please. All right, right. You just go with this. You are looking so good. I'm with the same face. Okay. But now what I'm to do with that? The blue group, you get one straw, and the red group gets a straw, and I get another. I take the same color, no problem. Now, can you blow some sound? Can you produce some sound out of this? No? Nothing much. You can do this. Oh, I'll do like this. 1, do it. 2, 3, 4, right? Yeah, now. Wow, I can do this. Oh, great. Vishwal, come here. Don't shake your hand. I'm very much scared of part 2 of Corona. Now you see, do it. Blow it again. Believe this. Pura Indian cricket team. एक बार appreciate कर दिया तो दूसरा दिन You can do it. I know that. I'm joking, right? I have the right to joke. I am cutting. I'm cutting for the sake of you. Now do it. Do it. You can do it. Can you try? You can do it. Keep trying. Oh, great. You are adopted. Now do it. Oh, great. Seniority should get the chance first. Now, please. Vishwal, be careful. God has given only one nose to you. What I can do is that I'm just below their level. I do here. So this type of fun. Now you ask to the questions. To the student, ask the questions to the students. Can you have this type of fun on the surface of the moon? Definitely. You people will say no. Why? No, yeah. That is the point I want to just put the question. Yes, there is a thin layer of air. You get the chance. To educate the people, to educate the students. I also getting the chance. There is a very negligible thin air that is called exosphere. There is air, but exosphere, almost negligible. Right? Compared to the atmosphere, it is not possible. Okay, we can talk a lot, we can do a lot, but we don't have time. It is yours. You are looking so good. Good back. Please clap to them. So now we have reached onto the moon, but now I'm just making it short. You know, on the surface of the moon, suppose that this is the daytime. I'm looking up and thinking about 12 men. I'm thinking about 12 men who already stepped onto the moon since 1969 to 1972. And one of them was David Scott. He did that beautiful experiment. He did that experiment with a hammer and a feather. I take this and I take this, right? He did it there. He reminded us. He reminded about the experiment of the cannonballs experiment from Leaning Tower of Pisa of Galileo. 16th century, right? And if you do this here, every time you will see that the heavier one is falling. First time those who told me that they are falling in the same time, sorry, I'm not agreed with you. If there were no ear now, it could happen. But if you take a video, you will see the difference. One is falling first, another is falling later, right? And this was done successfully, almost zero atmosphere on the surface of the moon. So what happened that I come with this strip of the paper. Which one will fall first? 1, 2, 3. Wow, it falls first. But now, if I take this, it's very easy, very easy. If I take this and over here, if I leave them, 1, 2, 3, they're falling in equal rapidity. There is no air resistance. Now, this thermocol is just protecting from the air friction falling same time. And that was done in 1972 by David Scott, right, on the surface of the moon with a hammer and a feather. But now I am there. I'm there. I'm thinking about their activities of 12 men onto the moon, right? And now, here is the experiment we would like to perform here. This is very interesting. When I was thinking about them, yes, my spaceship, the command module, it is just waiting up there for me. So many words. Yeah, I think this one. I think this one, right? Yes, it glows. Yeah, it glows. Please do not look at the light. Now, can you put up this light, please? Put up the lights of the show or the stage, please. The same question I can ask, as generally we do. Have you ever seen a red light? Have you ever seen a blue light, a green light, or a white or yellow light? Yes? What did you see? Huh? Traffic light? Okay. Okay, thank you so much. You get me a chance to do this experiment. See, I keep this, I take the second one, I take the third one, and I keep this, I take the second one, I take the third one, and I pour the liquid nitrogen, and artificial is invisible, enlightened observable, enlightened objects may be visible. And on the surface of the moon, according to you said that there is no air, or maybe some very thin air, no scattering of sunlight. And there is no scattering, if there is no scattering of sunlight, no sky. We are very much fortunate that we are living in the habitable, in a planet that is Earth. We have got a beautiful sun, Earth. Now I come to the part that is the thing I want to add here. It is getting ready. Before it gets ready, I'm going to show you something else, right? And just give me another 5 minutes time, please. Please put on the lights. I can't see. Can anybody help me? Can anybody? Please, as a shortage of time, just untie it. खोल दो. इसके साथ ये खोल दो. Right? And now, gradually, slowly, after doing our activity, we'll come back to our mother planet Earth, and yes, that, right? But before they have reached near to the International Space Station, the second stage, right? That is called flip maneuvering. It has to be done perfectly, and I will let it show you there. But before that I do this, I take this advantage of taking some liquid nitrogen, and I have a tongue. I take this ball, I keep that inside, and students, you people, please count 1 to 10. 1, 2, until then let me explain what is going on here. Acha, okay. I do it directly from here. What is happening here now? You know that there is one hole. It is tangentially met previously. And whenever I'm just dipping there inside the liquid nitrogen, the air is present inside the ball. It is getting contracted, right? So there is a question of partial vacuum. And now what happens that liquid nitrogen just enters into the ball through the hole. And when I take this out, I'm supplying heat. Why don't you clap the idea, yaar? When a rocket goes to the earth, it turns 1, 2, and then to save your fuel, right? And so gravity turn takes place. So what happens that? I'm supplying the heat. I'm supplying heat means what happens? That liquid nitrogen is now getting converted into gas. And when it is gushing out through the hole, it is making the ball spinning. But what happens? What happens if I do this? The same ball, you will say that you are repeating the same thing. No, I'm not repeating the same thing. I take this ball again, right? I hold it with the strong, and I'm sure I got your permission to do this. And now I'm doing the same experiment, but in a different way. See, I hold it, I supply the heat, but now the ball is not rotating, the ball is not moving here and then I'm not revolving around any point. Why? Trust me, there are 4 holes. And you people know that we do the same orientation of a rocket with the help of this type of cold gas. That is a flip maneuvering, right? And I think that they have already gone through this type of phases, and we are just about, congratulations Sudhanshu again, right? And thank you so much. Now we are back to earth. Suppose that, imagine that we are back to earth, and now I want 2 volunteers, one from the blue group, one from the red group. Please, hurry up. Just the last, next to the last experiment. And what is the drum? Give me the drum. Acha, I take the drum, no problem. I take the drum here, right? And I keep it here. At last. Oh, yes, please, both of you. Oh, my drama partner and our VI team partner. Please come. You two are here. Why you are here? What?
We are volunteers.
They are saying that for guinea pigs. Hey, don't say that. You are guinea pig. You are not my guinea pig. You are not my guinea pig. But maybe that you are my guinea pig. I take 2 balls. One for you. Please stand here. There, please, back there, back to him. And one for you, so yes. Now I think that I have the supply of water enough. This is the water from Bangalore. Yes. Get some water in your hand. No. In the hand. Yes, please. Thank you. And again in your hand. And trust me, I have a source of laser. Our atmosphere protects us from the dangerous solar radiation and from the meteoroids like meteors, right? What's the difference between meteors and meteors? Meteors are small, they can reach to the earth after burn. And from the meteoroids like meteors, right? What's the difference between meteors and meteors? Meteors are small, they can reach to the earth after burning. No, they cannot. They get converted into ashes. And fall collision, our atmosphere, maybe our life. See, the atmosphere is protecting. On the white balloon, you know the answer. It is not getting burst. Now, you boy, take it down. Wow! Clap to this, please. Thank you so very much. Oh, I got so brave. Assist. I don't say my colleague. Right. Thank you so very much. It is yours. Oh, no. Planet Earth. It has got the atmosphere. Atmosphere means it helps us to taste. Really rich. And I'm ready. I think that this is an auditorium. I don't take huge amount. I will try to do in a very small scale. That will be our experiment. When I say that 1, 2, 3, you people, it's my earnest request to everybody, please say spectacular show. Then giving big hands, program Samant. Now, this time we change the mode. As it is a very history today, I requested madam that please give me a chance so that I take that opportunity to pay our respect to the first Indian to reach to Indian International Space Station, to pay our respect to Shubhanshu Shukla and to say him congratulations, Shukla. So once he said yesterday, like, Rakesh Sharma, when our Prime Minister that time asked him, तुमको भारत के ऊपर से कैसे लगते हैं? उन्होंने बोला, मैं बिना हिचक से कह सकता हूँ, सारे जहां से अच्छा. कल क्या बोला हमारा शुभांशु शुक्ला? जय हिंद, जय भारत. So that will be our 4 words today. I will say 1, 2, 3. You people will say Jai Hind, Jai Bharat. Program will come to an end with forming the cloud. Are you ready? Yeah. So let's go for some rehearsal. 1, 2, 3. No. This is the voice. ये जोश है, ये जोर है. जब जोर से बोलो. 1, 2, 3. Sojalang Sufalang Malajo Sitalang. Thank you so very much. Jai Hind, Jai Bharat. Thank you. Namaskar. Thank you.
Thank you, Mr. Tarun Kumar Das, for the spectacular show we had. Now let's have a very quick 10 minutes break for tea, and let's get back in 4:25. 10 minutes break.